नमस्ते बच्चों, I am JVM Dr. Surendra Kumar Srivastav from the Department of Science under the Faculty of Education and Methodology, Jayoti Vidyapeeth Women's University, Jaipur. Today I will learn about the calculus of residue. Then first we see the working rule for the computing the residue. There are some formulas. Residue z is equal to limit z tends to a z minus a fz for the simple pole. And second formula, residue z is equal to a is equal to 5 to the power m minus 1 a upon factorial m minus 1 for the pole of order m if fz is equal to 5z over z minus a to the power m. Third formula, residue z is equal to a is equal to 1 upon 2 pi I integral c fz dz for pole of any order. Next, residue at z is equal to infinity is equal to minus 1 upon 2 pi I integral c fz dz. Next, residue at z is equal to infinity is equal to negative of the coefficient of 1 upon z in the expansion of fz in neighborhood of z is equal to infinity. Next, integral c fz dz is equal to 2 pi I summation r is equal to 1 to n residue at z is equal to zr. If fz is equal to phi z upon psi z has a simple pole at z is equal to a, then residue at z is equal to a is equal to phi of a whole upon psi dash a. Now we see the problem. Find the residue of z cube upon z minus 1 to the power 4 z minus 2 z minus 3 at z is equal to 1 2 3. For the solution, fz is equal to z cube upon z minus 1 to the power 4 z minus 2 and z minus 3. Here z is equal to 2 and 3 are the simple pole. Then residue at z is equal to a is equal to limit z tends to a z minus a fz. Residue z is equal to a is equal to limit z tends to 2 z minus 2 z cube upon z minus 1 to the power 4 z minus 2 and z minus 3. So limit z tends to 2 z cube upon z minus 1 to whole power 4 z minus 3 is equal to 8 upon 1 cross minus 1, this is minus 8. And residue at z is equal to I, limit z tends to 3 z minus 3 upon z cube upon z minus 1 to whole power 4 z minus 2 and z minus 3. So answer will be 27 by 16. And now the third, z is equal to 1 is a pole of order 4. So residue z is equal to a is equal to 5 to the power m minus 1 a upon factorial m minus 1. That is fz is equal to phi z upon z minus 1 to the power 4, where phi of z is equal to z cube upon z minus 2 and z minus 3. So phi z is equal to z plus 5 minus 8 upon z minus 2 plus 27 upon z minus 3. Phi dash z is equal to 1 plus 8 upon z minus 2 to the whole of square minus 27 upon z minus 3 to the whole square. Phi double dash is equal to minus 16 over z minus 2 to the whole cube plus 54 z minus 3 to the whole cube. And f triple dash is equal to 48 upon z minus 2 to the whole 4 minus 162 z minus 3 to the whole power 4. F triple dash 1 is equal to 48 upon 1 minus 2 to the power 4 minus 162 upon 1 minus 3 to the power 4. This is 48 minus 162 upon 16. This is 303 by 8. So residue at z is equal to 1. So residue at z is equal to 1 is equal to 5 to the power m minus 1 a upon factorial m minus 1 is equal to 303 upon 8 cross 6 is equal to 101 upon 16. Now we will see the another theorem. Question: Determine the order of poles and values of residue of the function at cosec z and second z plus 3 upon z minus 2z. For the first function, given that fz is equal to cosec z is equal to 1 upon sin z, 1 upon sin z. This is equation first. So poles are given by sin z is equal to 0, that implies z is equal to 0. So z is equal to 0 is the simple polar of fz. So from first, fz is equal to phi z upon psi z. This is phi z is equal to 1 and psi z is equal to sin z. Residue at z is equal to a is equal to limit z tends to 0 phi z upon psi dash z is equal to limit z tends to 0 1 upon cos z is equal to 1. Hence residue at z is equal to infinity is equal to 1. Now for the second, given that fz is equal to z plus 3 upon z minus 2, poles are given by z minus 2 is equal to 0. This is z is equal to 0 and z is equal to 2. Residue at z is equal to a is equal to limit z tends to a z minus 2 fz is equal to limit z tends to 0 z minus a z plus 3 upon z minus 2 is equal to minus 3 upon 2. And residue at z is equal to 2 is equal to limit z tends to 2 fz over z minus 2. So limit z tends to 2 z minus 2 plus 3 upon z plus 3 is equal to 5 plus 2. Again find the residue of z plus 1 upon z square upon z minus 3. Given that z plus 3 z square z minus 3 is equal to 0. So poles are z is equal to 0 are a simple pole of order 2 and z is equal to 3 is a simple pole. Now residue at z is equal to a is equal to limit z tends to a z minus a fz, that is limit z tends to 3 z minus 3 z plus 1 upon z minus 3 z square. So answer is 4 by 9. Since z is equal to 0 is a pole of order 2, so residue at z is equal to a is equal to limit z tends to is equal to phi of m minus 1 upon factorial m minus 1 if fz is equal to phi z upon z minus a to the power m. So fz is equal to z plus 1 upon z square z minus 3 is and phi z is equal to z plus 1 upon z minus 3. Now phi dash z is equal to z minus 3 minus z plus 1 upon z minus 3 to the whole square. This is minus 4 upon 2 minus 3 to the whole square. So phi dash at 0 is equal to minus 4 by 9 and the residue at z is equal to a is equal to minus 4 by 9 into 1 upon factorial 1 is equal to minus 4 by 9. Thank you.